Saturday, everybody. So welcome to the second part of the presentation. This one is called How Computer Science Changes the World. If you have any questions or comments during the presentation, feel free to just interrupt. Yeah, you don't have to wait until the end. Anybody have any questions before we start? So, before I actually start with content, I'll just give a quick introduction to who I am, because probably you don't know who I am. Yeah. So I joined the computer science department in 2006, which is already a long time ago. Before that, I worked at a place called the VRViz Research Center in Vienna, Austria. Anyone been to Vienna before? Nobody's ever been to Vienna? Shocking. Okay, I highly recommend, like, after this talk, get a ticket to Vienna. You definitely want to check it out. I wrote a PhD in Austria at the Vienna University of Technology. And before that, I was in the US writing some master's and bachelor's degrees. And the areas that I study are data visualization, information visualization, scientific visualization, and visual analytics, which are big themes in this department here at Swansea University. So the idea is just to give you a little taster into one of the themes inside the department. So Steve's talk was about general things, teaching and administrative things, and this is just a little taster into some of the research that we do. So we're going to talk about Sally's big data quandary. Are there any Sallys in the room? Anybody with the name Sally? There was somebody 2 weeks ago with the name Sally. I was shocked. Anyway, this was about her. So what is Sally's big data quandary? If you have a job or you've ever worked in a company, you might be familiar with this, or if you're a collector of some sort. So Sally discovers that she can collect data cheaply, right? Because she can collect data cheaply, she decides that she wants to collect a lot of data. So she collects data over years worth of data, right? After a few years of collecting, she decides she wants to do something with the data, right? She wants to derive some new knowledge, some insight from the data. She thinks, oh wow, I've been collecting these things for years now. There must be something there I can learn, some value that I can add on top. As she desires to discover something new and derive some new insight or information from her massive data set, she then realizes something that she didn't realize before. She discovers what a challenge this is due to the size and the complexity of the data that she's collected. So she discovers a gap that she wasn't previously aware of. So her ability to collect data and her ability to derive useful information and insight from the data. So there's a gap in between those two abilities that she wasn't aware of previously. It's like a magic threshold. As soon as the data set gets too big and too complicated, the gap appears. This is also one of the stages of learning. I don't know if anybody's ever looked at the 4 stages of learning before, but she's gone from unconscious incompetence. She was not aware that this gap existed at all, to conscious incompetence, which she discovers something that she doesn't know. That's one of the first stages of learning. So Sally is a metaphor for everybody. This is happening to everybody, everywhere, collectively as a society. This is happening all around the world, everywhere, even to you sitting in your chairs right now. You might not have noticed it yet. So it's the universal big data story and quandary. These are just some examples on the left column. These are examples from different professions that are collecting massive amounts of data and having trouble because of it. Computational fluid dynamics. Anybody ever heard of computational fluid dynamics? They like to work in secret, actually. There are tens of thousands of them in the UK, but they never talk to normal people. Anyway, there are probably 100,000 of them spread across the globe, generating massive amounts of data that they're struggling to understand. There are physicists and astronomers generating lots and lots of experimental data and image-based data, trying to understand it. There are marine biologists and computational biochemists generating massive amounts of data, struggling with. There are psychologists, sociologists, criminologists, all collecting data about people, right? We have sports scientists collecting data about events in sports, right? You're all watching the Six Nations right now, the rugby thing. What's the latest news there? Is Wales still in it? Wales is still in it? They're at the top? Okay, good. Well, I'm relieved. We have government councils like Swansea City Council collecting lots of data, trying to understand what the people in Swansea are doing. Those are just some examples on a professional level. But on this side, gets a little bit more personal, a little bit more individual. Something you encounter in your daily lives. So banks and customers, right? The banks are collecting data about every single transaction you make, stored in a database, right? Call centers are collecting data about every single call you make, right? Has anybody ever here called a call center before? How much fun that is. All that data is recorded, right? Whenever you buy something, all the data is stored in a database. The retail chain stores are trying to figure out the best way to take your money. Whenever you look at a website, right, that data is recorded by at least 3 companies, right? The web server, the company with the web server, the network company that's providing your internet service, and some local website administration site. Transportation, whenever you go somewhere, there's data being recorded about your movements, right? Healthcare, every time you visit a doctor, all that data is recorded. It's everywhere, right? This is everything, everybody. You are collecting things, right? You're collecting photos, you're collecting selfies, right? Some of you have a very impressive collection of selfies. You're collecting files. Sometimes you collect things you don't even want to collect the things, right? I collect email, right? Involuntarily. I get thousands of emails, right? I'm always trying to delete them. This is a universal phenomenon. This is everywhere and everyone. And it's a consequence of at least 2 things. One is cheap data storage, and the other is just that people like to collect. It's just human nature. We get some satisfaction from collecting things. Does anybody here collect anything? I know that some of you collect some things. That's a rhetorical question. When I was a child, my grandparents told me, they told my oldest brother to collect coins, and they told my second oldest brother to collect stamps, and they recommended that I collect keys, which are not so interesting to collect. So one of the what's my point? That this is a motivation. That was supposed to motivate what's coming next. That is data visualization. So data visualization is one of those topics that is supposed to help us resolve this crisis, this data collection quandary, right? So visualization is using computer graphics to generate imagery of real things happening, right? Of non-fiction, right, as opposed to fiction. And we're going to show an example of that right after this slide. So the goals of visualization, some of the goals are to explore data, right? This is the case when you don't know anything about the data set. Maybe you just want to figure out what it is. You're looking for trends, patterns, outliers in the data. You're not an expert about what that data is. Visualization is also good for analysis. So that's when you might be the person who collected the data, so you're already an expert with that data set, and you have specific questions that you're trying to answer, or maybe a hypothesis you're trying to confirm or disprove. Right? If I collect enough selfies, I might think, okay, I look better on Saturdays than on Mondays. It's also good for presentation. So once you've done your exploration and your analysis, and you want to communicate the results to a general audience, maybe an audience of managers, or at an open day, visualization is good at that. Visualization is also good for acceleration. So you can do some things much quicker using visualization than if you weren't using visualization. And we're going to see an example of that right now. I have different examples, but because we have this amazing World Cup happening, I'm going to go over the rugby example. So you could use data visualization to analyze rugby. How many people here are Welsh? Okay, good, perfect. So I guess you're going to be very interested in this. You might be shocked to know that you can use visualization to analyze and study rugby. So during a rugby game, I guess if you're Welsh, you know this already, there are people sitting on the sidelines recording data about every single event in the game, right? For every single event, they're recording lots of data. They're sitting there and they're inputting the data into their machines, right? For every event, they're recording the gain associated with that event. They're recording what kind of event it is, like a line-out, scrum, or turnover, etc. They're recording where the event started, right? The tortuosity is not something that they're recording. We derive that. That's the curvature, the path that the player took when they carried the ball. They record the number of phases, the direction the ball moved in, the net lateral movement, so not forward and backward, but from side to side. The time the event occurred, how long the event took, and the team identifier, or which team caused the event to occur. We can take all that data and map it to something visual, right? This is a glyph. We call it a glyph. And it's actually encoding all of that information visually, right? So the time at which the event started is encoded by this red arrow. So the starting time is at midnight, so this event occurred shortly after the game started. And the duration is encoded by the thickness of the arrow. The tortuosity, or the curvature of the player that the player took during their traversal, is mapped to the curvature of this gray line. The territory start position is mapped to the radius of this gray area. The color indicates which team is associated with the event or caused the event to happen. The net lateral movement is indicated with an arrow, this arrow. The number of phases is indicated with just the symbol. The direction of the event is encoded in the direction of this arrow orientation. The type of event is encoded as a pictogram in the middle of the event, and so on. And then the gain is mapped to color, this color. So we won't go into all the details. We'll just show a demo of that software and that analysis in action. I brought in my slow Mac today because I wanted to build suspense. Suspense is agonizing. So in reality, I have never seen a rugby game in the traditional fashion. I forgot to mention something too. That why would we even want to do this? Well, if we're a rugby trainer or a coach or a player or analysts, and we want to develop a strategy to defeat the opponent, I guess the Welsh want to defeat the English. That's like the holy grail, right? One way to do that is to watch all the games that the English play, right? To sit in front of the TV, with the popcorn and beer and a notepad and try to watch all the games, right? But that's a challenge, isn't it? To watch 10 games, right? And to try to figure out the patterns. It takes a long time, right? Probably nobody has the time to watch 10 games of rugby. And the other thing is to try to find patterns in those 10 games is very challenging, right? Imagine you see somebody score a try and you think, oh, didn't they score a try using on a lineup like 2 games ago? Maybe. Oh, maybe I should go back and watch the other game. So it's challenging, right? So that's why we use visualization to help us with this problem. So all the events are mapped to glyphs, and as soon as we map the events to glyphs, we can get a complete overview of the game in just a few seconds. So on the x-axis of this scatter plot, we have the game time right now, and then on the y-axis we have game. So we can get a complete overview of the game immediately. We can change the x-axis so that the glyphs are sorted by any of their attributes. So in this case, they're sorted by event type. And we see immediately that the lineouts are associated with the most score, or the most tries. Right? Try is represented by this purple halo. So we can see immediately, okay, for this particular game, this team was very successful at their tries using lineouts. Here we have gain on the y-axis again, and we have game time, but we can change the sorting criteria by any of the attributes that we want. And then the sorting criteria is updated on the x and y axes. And we can see that, for example, number of phases on the y-axis, that tries are associated with higher numbers of phases. We can modify the way the glyphs are rendered. So if the glyphs are overlapping, we can bring some glyphs to the front while others are in the back. We can use selection techniques, right, to bring some of the glyphs into focus and other glyphs into context. And we can perform different kinds of sorting criteria. Right? We can sort by even 3 attributes, not just 2, right? And that's what this video is demonstrating. So there's a copy of this video on YouTube if anybody's interested in watching it in more detail. There's also a copy of it on my webpage if you're interested. try to keep with the program. I'm gonna keep with the schedule. This is just a quick note that the work we do in the department has impact outside of the university, outside the ivory tower of the university. So this is our work being featured in the New Scientist, for example. So if you're looking out for these things, the Swansea University Computer Science Department has quite an impact outside, and you can see our work in most media outlets. This is the New Scientist. This is our work being featured in computerweekly.com. That's some visualization work from here from the department. You can find us in most things like the South Wales Evening Post or the BBC, where we get around in the media. So thank you for your attention, and I'm happy to answer any questions if there are any. Everybody's eager to be watching the rugby game. When is the next rugby game? The next Welsh game?
2 weeks.
In 2 weeks? Wow, it's a long time.